Hello. In this video, we are going to study about kinematics, which is an important topic in physics. Now, kinematics is simply said the study of motion without considering the cause of the motion. Study of motion without considering the cause of motion is called kinematics. And if you were to consider the cause of motion, then you would be studying dynamics. So that's the difference between kinematics and dynamics. Kinematics does not involve cause of the motion, while dynamics involves cause of the motion. Now, kinematics answers questions like how fast is something moving, how far has that something traveled, and how does velocity change? And there are certain key quantities in kinematics that are involved everywhere to study motion. These quantities include position, displacement, velocity, speed, and finally, acceleration. Now, starting with position. Position refers to the location of an object. It is a scalar quantity and it is represented with the symbol x. And then we have displacement, which refers to a change in position. So if you're changing the location of an object, that is displacement. Displacement is a vector quantity because when you talk about displacement of an object, you also mention the direction in which that object is being displaced. Now, mathematically, we represent it using delta x, which is equal to xf minus xi, which represents final position minus the initial position of the object. Next up, we have velocity, which represents the rate of change of position of an object. This is also a vector quantity that is mathematically represented by v equals delta x over delta t, change in position with change in time. And then we have speed, which represents the rate at which distance is covered. Mathematically, we represent it with v equals x divided by t, or just position divided by time. And this is a scalar quantity. And then finally, we have acceleration, which represents a rate of change of velocity. Rate of change of velocity. This is also a vector quantity, and mathematically it is represented by a equals delta v over delta t. Change in velocity by change in time. Now, each one of these quantities has its own units as well, and there are certain similarities between the quantities as well. For instance, position and displacement are very similar. Velocity and speed are very similar. In fact, in real life, people casually assume that velocity and speed are the same thing. And they do the same for position and displacement as well. Now, in physics, we have a proper distinct difference between them. Position is a scalar quantity, which means you are only referring to the length or the distance of an object. And then you have displacement, which refers to the change in position. You're comparing two distances with each other, and that is giving you the displacement, which also points out the direction in which the position was changed. And then we have velocity and speed. Speed is simply how fast something is moving. Velocity is speed but with direction. For instance, if you were to say that a biker is moving with a speed of 40 meter per second, then that's speed. But if you were to say he's moving north with a speed of 30 meter per second, then that is velocity. Finally, you have acceleration, which simply represents the rate of change of velocity, and it determines how quickly or how slowly an object is increasing its speed or velocity. Now, all of these quantities have their own respective units. Starting with position, it has the unit meter, represented by an m. Then displacement has the same unit, meter, as well, since they are both essentially the same quantity, but the difference is in the fact that one of them is represented by just a magnitude, while the other is represented by a magnitude and direction. The same goes for speed and velocity as well. Their units are similar to meter per second, written as m by s, like this. And then this one as well, meter per second, represented as m by s. Finally, acceleration. This is meter per second square. And it's written like this. And there we go. So that takes care of the quantities that should be discussed in that will be discussed in kinematics. Now, besides these, engineering students must memorize certain equations, which are also called equations of motion or the SU-VAT equations. So let's talk about them now. The equations of motion. I termed them as SUVAT because this is an abbreviation for displacement, initial velocity, final velocity, acceleration, and time. In the abbreviation, S represents displacement, U represents initial velocity, V represents final velocity, A represents acceleration, and T represents time. These are the symbolic representations for these quantities used in the equations of motion we will write down now. There are three main equations of motion, starting with the first one, which is V equals U plus AT, or final velocity equals initial velocity plus acceleration multiplied by time. Then we have another one, displacement equals initial velocity multiplied by time plus 1 by 2 or half of acceleration multiplied by the square of time. And then the final one is final velocity squared equals initial velocity squared plus 2 multiplied by acceleration multiplied by displacement. These equations are very commonly used along with the formulas written up here to solve different problems associated with kinematics. For example, let's see how we can apply them. Um, let's assume a car starts from rest. If a car starts from rest, we are going to say that its acceleration, let's say it is 2 meter per second square after starting from rest. Let's say that it moved with this acceleration for 5 seconds. Calculate the final velocity. So, when solving a question like this, you have to observe what you have been provided and what you are looking for. The question gives you acceleration, it gives you time, it's asking you for final velocity, and it also gave you one more crucial detail, which is not in the form of a number, but rather in the form of a word. It says the car starts from rest, which indicates that the initial velocity, u, is equal to 0 meter per second. So you have three details available and you have to find a fourth one. When solving this, you have to observe the equations of motion and pick out the best one to use in your situation. Now, our situation requires us to find final velocity. So first we have to choose a formula that does provide final velocity, which takes out the second equation, because the second equation doesn't have any final velocity in it. Then our question gives us acceleration, time, and initial velocity. We can't rely on anything that we have not been provided with. So that rules out the third equation as well, because the third equation involves displacement, which we don't have. Which means we can calculate final velocity using the first equation, because we have initial velocity, which is 0 meter per second. We also have the acceleration, which is 2 meter per second square, and we also have the time, which is 5 seconds. Now, if you were to simply solve this mathematically, you would get 0 plus 2 times 5, which is simply 10. So the final velocity that you would get here would be 10 meter per second. If you want more videos like this, check out the link in the description. It will lead you to our website where you'll find multiple courses for different subjects of engineering, as well as different resources like worksheets and notes.